Okay, this is the Tepid Coder. Today, I want to finish up my DLL slash SO slash .a slash .lib series here. I don't know if this is actually going to be the last video, but I'm at least going to talk about the last type of library, which is going to be an import library. I might in the future make a video where I do the same stuff, kind of like one massive video, but I do it all with Microsoft Visual Studio or with cl.exe directly through the developer's console. I'm not exactly sure which approach I'll take if I do that. Could even do both. It's going to be a long video though. I expect it to take probably about an hour. I don't know if people actually want to sit through that. Anyway, let's get started here. I'll make the same library I've been making here. Make an add. Let's make it extern C. Do I want to do that yet? Let's start without that, actually. Okay, we're going to have int A and int B. Return int B. So that'll be a C++ library for now. Let me think for a second how I want to do this. I think I'll start with my loader real quick. But I keep including extended libraries. I don't need that. Okay, int types page. Do entry point. Okay, and it's going to be, I don't know, let's say 6.7. Okay, it's going to call the function so you can see it working fast. Come on. Yeah, it's going to be add. It's going to be, what did I say, 6.7? I'm going to need a function signature, int add, int. Okay. I'm going to need to actually link this. I'm going to say G++, shared library I'm making out of it. This is a bit interesting too, because the process for this is going to be slightly different for Windows import libraries, I think. Because the SO file has more information than the DLL file on Windows, but you actually can create an import library with an SO file that's made with MinGW. So, first of all, I'll compile it, making a shared library. And it's going to be add.zp, show, I'll call it add.dll. Okay. So that's created. What else do I want to do here? I think the next thing I want to do is going to be calling gindef. I'm going to say I want to make library, the library I'm making, right? So it's going to be add.dll. So generate the definition for that. If I check that, that should be in here now. So here it is, add.def. So it's cat add.def. So there's the name mangling it's doing for us. This is going to tell the next program I do how to basically create a import library out of the DLL file based on the name it needs. I'm exporting add, but it's add with this weird mangling. Okay, what else? We have something called DLL tool. We -k --output-lib. It's going to be add.lib rather. This is my export library. In fact, I'm going to call it import add or something, .lib. And then I'm going to say --def. The input definition file is one we just made, which is called add.def. Okay, it doesn't know that. Now, in my system, I know the path for it is going to be C in sys 64 GW 64 in gindef. Wait, what am I saying, gindef? Oh. Sorry. Is that really not recognized option outlib? Oh, it's output lib, not outlib. Haven't done this in some time. There we go. So, geez, what did that make? We should have a new file in here. Here it is. Import add.lib. So now if I actually link it, I need to link it against this lib file. I think I'm going to link... Where is it? Did I make a loader? Here it is, loader.cp. Okay, so I'm going to say g++ loader.cp dash capital L. This directory is where it's coming from. Dash L with lowercase is going to be the name of the library, which is import add.lib. And the output file is going to be loader. It doesn't like it because cannot find import add.lib. I'm gonna use that colon syntax again. Now it's happy. Okay, loader, and it works. I'm really glad I found out about that colon syntax. That has been causing me grief for years. I'll try every combination of like having lib in front after .so after .a after no a no .lib or no .so. You can imagine every combination of existing and not existing and what side it's going to be on. I don't even know what that would be. Imagine you have something to do before and after as too, and you also have something else which could be like .a or .so. It could be there or it could not be there for each. It's like 2 times 2 is like 8 options or something. I don't know. That's neither here nor there. Point being, you saw that it worked. However, this is still going to require that this DLL exists. So I'm going to remove the DLL. rm -v add.dll. Okay. Now I'm going to try and run it again. See what happens. Doesn't work. It's because I couldn't find the DLL. Now if I actually try to run it from here, I'm going to get an error message. The console doesn't give it to me, but it says add.dll is not found. So that's kind of interesting. So you might be asking, what's the point of this then? If you still need the DLL, why have a library at all? You know, let's rebuild that real quick. Where did I compile that? Jeez. Right here. Okay, now it should work again. Right, it does, okay. So the point is, I go into my loader.cp, oops, cpp. What I don't have to do now is I don't have to say, include, say, dlfcn.h, and then use like dlopen or dlsim and dlclose, and I don't need to include windows.h to get access to, load library A or W, or get proc address, or free library, and I don't need to, not just this, and like maybe also like the calling conventions, etc, or whatever. I also don't need to, when I call get proc address from like h library, let's say, of the function name would be add, except it's mangled, it's like that, was it z3 I think, which would actually work. I don't need to do this garbage, where you have an actual function pointer, call it add, takes 2 ints, equals, but I can't just say it equals this block of memory because this returns a void pointer. Jeez. I have to cast it into this actual type, which is, the type is a function pointer, which returns int and takes 2 ints. So I'm casting it to that and then getting the proc address. So I don't have to do any of this. I don't have to worry about freeing it when I'm done. I don't have to worry about loading it. And actually, in the previous example that I gave, let's see here, code libraries 2, I think it was in this one. Is it loaded 2 CP? No, it was in the first example I gave. Okay, it's in here, and I think, loaded 2 CP? Yeah, in here. So actually, just to show why that's actually kind of nice, you don't have to do all this, I had forgotten, in this case, when it couldn't find the function. We load the DLL, but couldn't load the DL, give up. Okay, but if it can load the DLL, try and find the function. If it couldn't find the function, I was just giving up. I forgot to close the DLL, right? It wasn't bringing resources. That could actually be an issue if it's like, maybe I'm loading the DLL on the fly. Maybe there's some command I can press inside of a program I'm making that's going to cause the DLL to reload. But, if any error happens, I'm leaking memory and holding the DLL open as a file resource with the OS. Like, this is a good reason to maybe wrap these things in objects, right? In that case, I could have had something like class, call it DLL, like a DLL class, right? And then I could have something like private, and then say, in this case, it'd be a void pointer, right? LVV, DLL, it's a member, so then starts out as null pointer, public, blah, 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 whatever. So I get down here to the destructor, DLL, and what I would do is I'd say something like LVV, DLL, right? If it exists, then maybe do DL close on it, and DLL. right? And then I would just have like some kind of DLL object. I'd pass it some constructor, right? Just in loading this. Maybe it does now by default. That's something I didn't actually show before, is how to use the second flag right here. It can be now or it can be lazy. Lazy means it doesn't actually load the functions from the DLL until you actually try to call them. Then it'll load it for the first time. And once it's loaded for the first time, it's stored in memory like a table of function pointers that it can access. Anyway, if I do it this way, I have a DLL file, DLL object rather, then maybe I can do something like, you know, get function address or something, and then I can do the same kind of like casting or whatever. When this goes out of scope, right, it would be calling this destructor and closing automatically, so it would handle those errors for me. Either way, I fixed that, and when I post this code onto GitHub, that's going to be fixed already for you. What can I say now? Right, so I don't know if I want to do an overview, because you can always just look at the previous videos, but essentially, I guess I will anyway. There's basically a couple options. You have .dll or .so file. You can essentially load it yourself using, you know, let's say when API or functions from DLFCN, right? Or you could link it at compile time. Now, for DLL files, you cannot do that on Windows, right? This is going to be a MingGW specific thing. You'd have to use an import lib if you wanted to do that. Okay, so if you want to avoid having to do this junk, like I just showed, where you're loading it manually and finding the address of each function, casting and all that, then you want an import library if you still want to use a DLL. If you don't want to use a DLL, you just want a static library that you can build into your actual executable. You don't have to redistribute it. Then you want .a file or .lib file. Now, it's confusing because the .lib could be an import library, right? Or, you know, I don't know what else you'd call it, just a static library. With these, it's just going to build into your actual executable file. It's just confusing because this could also be an import library with a .lib format. And technically, I guess it could be that with a .a too, because that's what I just called it with this example I gave. Now, why might you want DLL? I don't know if I actually ever mentioned that, rather than just statically linking things into your project. I mean, obviously, if someone already has a DLL in your system, you can distribute less stuff. They don't need 100 copies of the same DLL if they're already going to have some DLL. Like a common one you might have is something like zlib, right? zlib1, whatever it's called. That's on a lot of machines, just by default. So there's no reason to have to distribute that all the time. You can probably just expect that the user's going to have that on the system. But if it's your own custom thing that only your application uses, then it makes sense to have to distribute it. But then why would you even use a DLL, right? So the reason you might want to do that is because if you update your program, you don't have to send in a completely new version of the program. You could just update the functions of your program that have changed by keeping certain functions that you want to use in your program isolated into discrete modules. So maybe you have something like, what's a good example? Maybe you have a game you made, okay, and inside the game you have something like, I don't know, your netcode, right? You have your rendering code. You have something like your, I don't know, controller code. In fact, let's call it input, right? Input, which could be keyboard, mouse, joystick, whatever. That could even be like a microphone or something. Maybe you have something like database code. Maybe you're using something like SQLite 3 or something to store settings files, or like someone's progress in the game. Anyway, you could put each of these in their own discrete DLL files, and if there's some change to the netcode you need to make, like maybe you've added encryption or something, you could still be using the same functions like, I don't know, send data or something, let's call it. You send it over some socket, and maybe you have like a void pointer, probably const void, to some data, and then you'd have something like size t, like size and bytes. And maybe this ends up automatically encrypting based on some value you set. It could be some state inside the DLL. In that case, I mean, you could just update it. You could even have some kind of like reserved, right? You could pass some structure to it. I don't know. Point being, you can update these things just by giving your user a new DLL file instead of giving them a whole new exe file. That's kind of nice. It's also nice for development. So if you're making a game, sometimes you'll be updating the render code, and maybe there's like new kinds of things you can render, like a sprite. Or maybe you can render a whole map of sprites, or maybe you can render like a new animated sprite type. whatever the case may be, you could have that in a DLL. And as you're working on your game, you could have your engine running, and you could hit a hotkey and just unload the DLL by pausing the game, so it's not accessing those functions while it's unloaded, and you reload the DLL, and unpause the game. And you could just keep running the game, just like you would recompile the entire project. If you didn't do that, and this is part of the actual game code, you'd have to recompile the entire game each time, which might take like 40, 50 seconds to compile the thing. It could be a lot longer. It depends how many templates and stuff you have in your game. So I hope that's a good explanation for why you'd probably use a DLL. And how an import library is a bit more convenient if you do want to use a DLL than having to manually load everything yourself. And I've already gone over the static libraries, which just adds things to your executable file, which is by far the safest way to do things, because you're guaranteed that any of your users to whom you distribute the application you build will have the exact same code being run, not code from an older or newer DLL or something that might cause issues. Okay, I'm definitely going to have more videos on this, because there are things like different, how do I say this? I'll save it for the next video, but the way memory is handled, geez, in DLLs is kind of something you need to keep in mind, and the way class objects are initialized in DLLs, and even how you work with classes in DLL files is kind of something that needs to be considered. Alright, like usual, if you have any feedback or questions or criticism or things you'd like clarified, expounded upon, whatever, feel free to comment, leave feedback. If you like what I'm doing, then like the video, subscribe, whatever. But have a nice day. Catch you later.